we are covering the last part of Chapter 11 that we're going to be covering. And that's surface area of spheres, the surface area of a sphere. Now, we do have an overall equation. The surface area of a sphere is equal to 4 pi r squared. So the surface area for any sphere is 4 pi r squared. So as long as we know the radius, we can find its surface area. So let's look at these first ones here. Now the first one that we have here, the radius is 8 inches. And we want to find its surface area. Now as we just saw, the surface area for any sphere is 4 pi r squared. And they told us that the radius is 8, so we can go on and plug that in. We'd have 4 times pi times 8 squared. And if we wanted to include units, it'd be inches squared. That's it. Any questions on our first circle that we have here? Finding the surface area of this here. Now the next one that we have is this circle here. Now they told us C is equal to 12 pi. Well, C is our circumference. So they didn't give us the radius. But we do know that the circumference is equal to 2 pi r. So circumference, so the 12 pi is equal to 2 pi r. So for these here, we have to find the radius first. And once we find it, we can plug it in. Now we would divide both sides by 2 pi to get r by itself. Because the 2 pi and 2 pi would simplify, leaving us with r is equal to 6. So the radius for this circle is 6. And now that we know the radius, all surface area is equal to 4 pi r squared. 4 times pi times 6 squared. Yeah, so for that one, they gave us the circumference, and we used it to find the radius. And once we found the radius, we can plug it in. Any questions on either one of these here? Are we good with this here? Let's look at the next one. So for this next sphere, they told us that what? The radius is 3 feet? Huh? It's the whole thing, so it's not the radius, it's the... It's the diameter. Diameter goes all the way across. So if the diameter is 3 feet, the radius would be, because the diameter is twice the radius is half the diameter. So we can divide 3 by 2 and get 1.5. So the surface area of this here is going to be 4 times pi times 1.5 squared. And again, we can plug this straight into the calculator. And it goes on farther than that. Because of the 1.5 squared, since we have a decimal there, it's converting everything into a decimal. So we get a massively long decimal for this one here. Any questions on letter A, the sphere with a diameter of 3? Now the next one they gave us, they told us that the circumference is 15 pi. Well, 15 pi is equal to 2 pi r. We're going to have to find the radius first. We have to find the radius first before we can solve. So the first thing we can do is divide both sides by 2 pi, which tells us the radius is 7.5, which means now we can use our surface area, 4 pi r squared, and we'd have 4 times pi times 7.5 squared. Start one more time. 706.85. And that's it. Any questions on any of this here? Bless you. All right, so since this is the circumference, so we'd say 6 pi is equal to 2 pi r. Because circumference is 2 pi r. So to find the radius, we would divide. Those would cancel. Our surface area is going to equal 4 pi times 3. And that'd be it. Any questions on anything we've done so far? Do we feel comfortable with these here? Yes. Good? Are there any questions on how we find the surface area given the diameter, radius, or circumference? Do we feel comfortable with these? Yes? So if we move on to the next part, we're fine? Okay. Now the next thing we're going to look at is going the other way around, finding the diameter or radius given the surface area. Now, we know that the surface area, the formula for surface area is equal to 4 pi r squared. That's our formula. Now, we want to find the diameter eventually, but we do know that the diameter is equal to twice the radius, and the radius is half the diameter, so we can get there. So if we can find the radius first, it's not too hard to get from the radius to the diameter. Now, the one thing that we do know, and the really only thing we know, is that the surface area is 20.25 pi. So we can plug that in. 20.25 pi is equal to 4 pi r squared. So we have this set up. Now we want to get the radius by itself. So the easiest thing to do first is going to be divide by 4 pi because these will cancel. We can divide this by 4 pi, which will give me r squared by itself. Do we agree with that? So I think that's a little small. Now, one thing that we can do is, well, pi divided by pi, anything divided by itself is 1. So really we're taking 20.25 and dividing it by 4, which is 5.0625. It'd be nice if we'd actually got a nice number, wouldn't it? Just taking the square root of this thing, because to get r completely by itself, we do have to take the square root of 5.0625. Well, that's actually kind of convenient. Any questions on this here so far? So the answer for this question is 2.25. because it wanted to know the diameter. So we just take this and multiply it by 2, which gives us 4.5. Because 2.25 times 2, or 2.25 plus 2.25, will give us 4.5. And that's it. That's all we have to do for this here. Any questions on any of this here? Let's look at another one. This time they told us that the surface area of this sphere is 144 pi centimeters squared. So again, we're still using the fact that surface area is equal to 4 pi r squared. We can fill in what we know. What would we do next? We divide both sides by 4 pi. Because on all the list of things that we can do to get r by itself, dividing is going to be easier than taking that square root, because we'll want to do that first. R squared equals, well, pi and pi cancel, so 144 divided by 4. Squared. Diameter is. Now really when we take the square root of both sides, it would be plus or minus 6, because negative 6 times negative 6 would be 36, and 6 times 6 would be 36 as well. But when we talk about a radius, we're talking about what kind of measure? A length, yes? Is length ever negative? No. So we take out the negative case. We don't consider it, since we're talking about just a straight length, a straight distance. Questions on this here? Now, will distance, especially a value of r, always be positive? Well, no. There's some cases where we can talk about distance in a negative unit, but we're not talking about rectangular coordinates. Think of an xy coordinate plane. A rectangle is length times width. We go over and up, yes? So the entire xy axis is considered rectangular because it's all pretty much rectangles. We have squares, where how we move from one point to another, yes? When you picture xy, it's over and up. Polar is dealing on a circular. It's a different way to measure. And when we talk about negative units, really, we could say that this is 2, but if I went opposite direction, it would be considered negative 2. And that's really talking about polar coordinates, ways to write numbers. So that's a different type of unit, different type of way to do it. And we won't cover it in here. That'll be pre-calculus. Covers that. Any questions on finding the radius or diameter on these here? Okay. If we feel comfortable with this here, the last thing we're going to look at is a hemisphere. So a hemisphere is half of a sphere, yes? So if our formula for a sphere, the surface area of a sphere is 4 pi r squared, well, we can take that and divide it by 2 because we're cutting it in half, yes? But that's not quite it, because when we talked about a sphere, we didn't have a base. But when I cut it in half, I add this flat part. I add this surface to it, yes? So we have to add that back in. Now the surface area of our actual sphere, the whole top piece, is going to be 2 pi r squared. But because where we cut, we created a face, we have to add that back in. So for a hemisphere, the surface area is 2 pi r squared plus pi r squared because we added a circle. The base of it is a circle. Oh, wait a minute. 2 pi r squared, they both have r squared, yes? Pi r squared. So they are like terms, which really means so the hemisphere is actually 3 pi r squared because they add that extra base into it. Questions on this here? So these here, we're going to have 2 parts. Most of them, probably the homework's going to do the same thing. If it doesn't, that's perfectly fine. Because here we're going to find the curved surface area of the hemisphere. And I'll just call it SC, surface area of the curved section, is our 2 pi r squared, because it's just the curve, the dome of it. It's 2 pi r squared. Well, the radius, they told us, is 7, so we'd have 2 times pi times 7 squared. So the whole curved part of it is 98 pi. Any questions on how we got the curved area, surface area? Well, if we want to find the whole thing, we can do 3 pi times 7 squared. I have a feeling it's just going to ask for the overall surface area. It's just not going to ask for the curved in total. But if it does, this is really all we have to do. The curved part is going to be 2 pi r squared. It's cut in half. But since we cut it in half, we added a face, so we have to take its surface area. Questions on this here? We're ready to look at another one. And I think we need one more, or it'd be nice to look at one more, and I think y'all about got this, yes? All right, let's look at this one here. So they want us to find the curved surface area and then the whole surface area. I'll call it SC. Well, this is our 2 pi r squared. And our radius is yep, 162. Because that does need to be squared. Now to find the total surface area, we use 3 pi r squared. Any questions on any of this here? Any questions over anything we've done so far? Okay. And that is